Hi everyone, we are continuing our talk on section 2.3 on getting information from a graph. And I said we would go into our textbook and look at some of those definitions. I don't like to write the definitions all the time in my lectures simply because you have access to the textbook, so you should be using your textbook as well. So I'm going to go into our textbook and look at this definition for increasing and decreasing, just so you can start reading more mathematically. As you progress in mathematics and get into higher and higher levels of mathematics, you want to be able to start learning how to read these definitions and things like that. They are confusing because math is another language. Okay, this first one says that f is increasing. Okay, increasing, we understand that term from English. Increasing means getting bigger. On an interval, and they say interval I, so they're just naming some interval. If f of x1 is less than f of x2, whenever x1 is less than x2 in I. And I'm like, oh my gosh, we got lots of different pieces here. So let's break it down. Okay, first of all, when you're talking about f of something, we're talking about y values. So we're talking about a y value at one point being smaller than another y value at another point. And they're saying that x1 has to be smaller than x2. So let's look at a picture. Here's our picture of increasing. Put some point x1 smaller than x2 on the number line. Could have been here, could have been on this side of the number line. It really doesn't matter. We're saying increasing if this guy is going to be smaller than this y value. So they are going to be going up. Here's our decreasing. If x1 is less than x2, notice it didn't change. And that is because we're reading from left to right. So as we go from left to right, our x values, our y values here get larger. In this case, our y values get smaller as we go from left to right. So there's kind of like the definition of increasing and decreasing. All right. I'm going to talk here is our definitions for our maxes and mins. They are on a separate page. And I did write those down in the last video. My picture didn't have a very good maxes and mins, so that's why I wanted to look at a different graph. And what we're looking for is when we're looking for a maximum, a local maximum, that means we're looking for little high points. Okay, a spot that you are bigger than your neighborhood. So in a little area around you, you are the big guy. So here we have a local maximum here. We have a local maximum here. These guys here are considered local minimum values. So we can talk about being low points in and around you. As you progress into mathematics, we will also introduce something we call a global maximum or a global minimum. And that just means the biggest of all. So if I were looking at this picture, and this was my entire picture, not that these kept going on. If these kept going on up and this one kept going on down, we would have no global maxes or mins because this continued to increase. But if this stopped and this stopped, I would say that this point is still higher than everybody else. Kind of looks like it's a little higher than this one. So this would also be a global maximum value. And when we talk about the maximum value, we're talking about the y value. If we're talking about where it happened, then we start looking at the x location. So x is the location, y is the value. So y's are the values of functions at certain locations. Hopefully that kind of makes sense. So we've talked about increasing, we've talked about decreasing. The last thing we have in this section is nothing. So I guess that is it. So I was thinking we were going to be doing more, but so if we're looking, let's just look at another picture. I'll look at another function. So here's another graph. I'll look at this little guy down here. Okay, first thing I want you to notice is your scales. 5, negative 20, and 20. So kind of pay attention to those. It does give you the equation of the graph. Okay, I can zoom in a little bit closer maybe. Let me see if I can zoom in here. There we go. There we go. All right. If we wanted to know where this thing was increasing, again, we're talking where. Not what are the values that it increases through, but where it is increasing. It is increasing for these values here until we hit somewhere in this high point. And this high point is going to be considered a local maximum. And it does kind of talk us through that we do have a local max somewhere between -1 and -2. We have a local minimum somewhere between 1 and 2. Okay. If I wanted to get a more accurate picture on where those are, that's where calculus is going to come into play. Calculus will allow us to find those maxes and those minimums better. So be prepared to look at where do we get the maxes from? Where do we get the minimums from? And we'll be able to tell that it is indeed increasing in this point. It is decreasing from here to about here, and then it increases again from there on. So again, increasing, we're going up. Decreasing, the values are going down. We usually ask where does that happen? When we talk about where, we're talking about x values. When we are talking about what is the value of a function or what is the maximum value, we have a maximum value of about, I'd say, 10-ish. Somewhere between x equaling -1 and -2. We have a minimum value of about, well, I don't know, maybe -8. Kind of guessing, I'm eyeballing it. And again, that minimum value of -8 happens somewhere between a 1, x equaling 1 and x equaling 2. Calculus would allow us to find those things more accurately. So this ends section 2.3. Hopefully some of these topics make a little bit more sense. And keep practicing, keep asking me questions, keep emailing me your questions, keep practicing on WebAssign, all of that fun stuff.